Here, let's do a quick example. 1 second. Okay. Let's suppose, so I just wanted to do an example of the photoelectric effect. And I hope this example will give you some ideas about how to deal with the data you're going to get in this experiment. Suppose we do the photoelectric effect experiment, and in the experiment we use photons that have an energy of 5 electron volts. That would actually be in the ultraviolet. And let's suppose that we measure a stopping voltage of 2 electron volts. From these two pieces of data, we should be able to work out what the work function is. Okay? In the actual experiment, you have many points, and you combine them to make a plot, which you fit to get the work function and h over e. But this is just an example. Okay? So we can do this because we know that the stopping voltage is related to these quantities. There we are. And so if we solve this for the work function, we simply get hf minus v sub s times e. Okay? And now we can go ahead and put in values and turn the crank to find the work function. Now, the most natural thing would probably be to use SI units for this project, just as we do for everything else. And what I'm going to show you is that while that works, it's a little cumbersome, and this is a case where it's actually more helpful to use atomic units or a different set of units. So first, with SI units, we have the work function is equal to HF, which is 5 electron volts. Now we have to convert to the SI unit of energy, joules. So we multiply it by 1.602 times 10 to the minus 19 joules per electron volt. And then we're going to subtract from that 3 volts. Okay. Oh, I'm sorry. I think I've made a mistake here. There we are. 2 volts times the electron charge, 1.602 times 10 to the minus 19 coulombs. And what we get, of course, is 3 times 1.602 times 10 to the minus 19 joules, or 4.808 times 10 to the minus 19 joules. Okay? Now, that's our answer, and there's nothing wrong with it, but it is a kind of very small number. It's hard to get a mental picture of that. So it's convenient to rewrite this in terms of electron volts. And to do that, we're going to divide this quantity by 1.602 times 10 to the minus 19 joules per electron volt. And then the answer will come out in electron volts. And oh, it comes out to be 3 electron volts. Nothing wrong with that. We're all done. We've got our answer. But it might occur to you that there was an easier way to get this answer. Okay? So instead of using SI units, we could have used what I'll call atomic units for the moment, just to give it a name. And by this, I mean units where the energy unit is electron volts, and the unit of charge, instead of coulombs, is electron charges. Okay? In these units, then, the work function is just 5 electron volts minus 2 volts times 1 electron charge. And so that's 5 eV minus 2 eV, 3 eV. So the photoelectric effect is one case where it actually makes sense not to use SI units, but instead to put your energies in electron volts and to measure electron charge in units of the electron's charge. I'm sorry, measure charge in units of the electron charge. Okay, great. Bye.